So our first stop into moving beyond what I'll say the VM and the infrastructure as a service, we've been looking at where our customers are going, what they've wanted, and obviously containerized workloads, Kubernetes is huge. It's beyond its traditional hype cycle, and it's becoming much more of a reality, especially when you start getting a call from a customer that says, yeah, I've just moved an application from test dev and we're playing around for a year into production, and now I need to start thinking about all of the things that I've traditionally done with VMs. How am I going to back this up? How am I going to protect it? How am I going to move it? How am I going to migrate it? And those use cases start becoming more of a reality. So I'm going to talk about what we're doing in this space. So to level set and just to start, hopefully, you're all familiar with the value of Kubernetes, but at a high level, how I kind of explain it or how I kind of view it is Kubernetes is all about agility, right? It's about being able to break that application into smaller components using microservices so that you can iterate on individual components of an application so you can get it out faster, and hopefully you get it out faster, you beat your competition at what you're doing, and it results in, better revenue for you. So it's all about business agility. And on the back end, from a development side and from an operations side, what Kubernetes does is really provide that abstraction level. It takes away the need for having to define a VM in a traditional sense, having to deal with operating systems, et cetera, having to deal with scheduling, and it really enables that continuous integration, continuous delivery of applications. It's really the underlying application. And the developer side of me absolutely loves it because it lets me work on my component without worrying about large teams. And from the IT side, from the technology side of me, I love it as well because it allows me not to have to worry about traditional infrastructure. I can define essentially infrastructure as code. So Kubernetes provides a lot of great capabilities. I'm sure you're familiar with that. It'll scale my workloads automatically based on parameters I define in the application. It'll monitor my workload. If my container crashes or my pod crashes, it'll bring that environment up. It'll scale it up. The example I love of this is Niantic's Pokemon Go. It's a wonderful case study of exactly what's possible with containers. As if kids are indoors and they can't play anymore, it scales it down. If people are outside, then and using it more, then it'll obviously scale that up. So that takes care of that component as well as managing storage. Over the years, it has evolved, especially with the CSI framework, in order to really make storage universal across the environment. And of course, being service defined, it takes care of the services and the components. But what we're finding is, as traditional enterprise customers that are putting more Gen 2 applications out, that are defining more cloud native applications, is that they want all of the service levels that they've been used in the past. So it's still maturing in places around disaster recovery and backup. In fact, just if you're following the releases, just with 1.17 recently, they took out of alpha and moved it into beta the ability to do snapshots at the CSI level, right? Something that if you're coming from the traditional VM or even physical world, we figured that out, years ago. But you can see the evolution, the steps that are happening in this space. We don't have something like the ADP to be able to, a universal backup API. We don't have the ability to easily move workloads across clusters. The idea is, just recreate the workload in a cluster. Yes, but there's orchestration involved with that. And again, if you've dealt with it from a VM-centric world or even an infrastructure as a service-centric world, the complexity involved just with the orchestration components. We want it easy. We want it kind of foolproof. And this is where we saw an opportunity working with our customers, and we've been developing this since about last August, and how we can bring the Zerto-like experience, the journaling, the continuous protection, the consistency groups, all the things that Heise has covered into a Kubernetes landscape. The other important thing when you kind of look at the protection is you'll hear, and I'm sure you've heard, and if you've used it, you're going to agree with, the container shouldn't matter because you should be able to recreate the container. However, as you're deploying applications, data's got to be written somewhere. That data has to reside somewhere, and that's usually the data that needs to be protected. So there's also this evolution that we've noticed in the last year or so in the industry, where containers started out purely stateless. So I'd still have my state running in VMs or physicals, wherever traditionally it's run, but I would use containers for those front end things that could go away, come back. So web services is a perfect example. But that only allowed me to be agile in a small part of my environment. And if the persistence was in VMs, we already have a solution for that. Heise has done a fantastic job of explaining what we all provide from a resiliency standpoint on that platform. What we then saw was this evolution to say, okay, how do I get out of having to run in let's say it's in a database in a traditional VM environment, and an easy way out was really utilizing database as a service that's provided by various platforms. So you can think of it as public cloud platform providers, or even some of the database providers will provide their components as a service, which means now I'm not worrying about the operating system, I'm not worrying about the application layer managing the database. I'm just using it as a service. So it gets us closer to achieving that overall agility and that CI/CD process. However, it's still tied down, right? And I'll kind of get into more of the specifics here. And then ultimately, we've seen an uptick considerably in actually putting the data with the container itself or with the pod itself using persistent volumes. And that's where we intersect and we start providing considerable amount of value. So I talked about database as a service. Yep.
So when you talk about the data persistency in Kubernetes, are you talking about things like the durable functions and things like Akka clusters kind of thing, or what are you talking about?
I'm specifically talking about the persistent volumes where you would instantiate and put your application data.
So that would be durable functions, right?
Yeah, correct. Yeah.
Okay. Thanks.
Yeah, no worries. So from a database as a service, and we use this, we've evolved even in our SaaS platform itself, going from infrastructure service to exploring database as a service. And what we found and talking to a lot of customers as well is, yes, it's great and easy to get started, but there are a couple limitations. One, you're obviously locked into the platform. And the whole idea of containers is I should be able to move it to anywhere. I should be able to run it on my laptop today and move it out into global production tomorrow without having to test it and from a platform standpoint. That's one of the core fundamental benefits of using containers, pods, and Kubernetes applications. The other is I'm limited to what I can do from a CI/CD standpoint. While I can CI/CD part of the application, so I've moved from more of just the front end to more of my core application, my back end still has to rely on a static service. So this is where we've seen a considerable amount of uptick in persistent volumes. This really allows the DevOps folks, the organizations, the developers, the company to be fully independent in terms of their microservices. If I'm deploying out, let's say, a service that you're all going to use, it gives you the time of something, a universal time that the company goes by. I can develop the database that I want as part of that, and I can make that fully autonomous, and I can deploy that anywhere I want and provide it truly as a service without having to rely on an external. So it really drives to that agility. And now I can include all my database components and my persistent components as part of that testing process as well. So it really is, from an evolutionary standpoint, the nirvana of achieving full agility with CI/CD and exploiting microservices to their full end. And it also allows really good abstraction and I won't say division, but really good division of responsibilities between what developers, DevOps, and IT are going to do in terms of delivering that application out. But with that challenge, with that architecture, there comes a couple of challenges, which arguably exist no matter where you put your persistent data. We have to worry about not only the DR aspect of it. So if something were to happen to your local cluster or wherever production is running, what does it take to bring that up to a remote target cluster? But also just Heise called operational recovery, the day-to-day, oops, a file got deleted. Because while the technology has changed and the architecture has changed, that person between the keyboard and the chair has not changed. So the same type of errors will happen. You know, we build processes to obviously eliminate that, but it still does happen. There's that aspect. Still prone to attacks from external entities that are unfavorable. And obviously, as the environment matures, we kind of start thinking about mobility, which is how do I start moving the application? How do I start recreating it, but I do it more efficiently with the app persistent data as well. So this is where we kind of intersected these challenges and these opportunities and introduced just a few weeks ago Zerto for Kubernetes. And very simply, from a definition standpoint, it is continuous data protection. So to my knowledge, we're the first folks to introduce continuous data protection for containerized workloads, along with disaster recovery, mobility, and for data protection in general for Kubernetes applications. The other important aspects about this in our architecture, which I'll get into, is it's obviously for persistent data, which is what you care about. If you have ephemeral workloads, you probably don't care about the data as much. But from an architecture standpoint, and from a platform standpoint, we changed our architecture so that it is truly hybrid. What I mean by that is we don't care about the platform that it's running on. So again, just as an example, referring back to something that Heise talked about earlier, we don't have to rely on necessarily the services the hypervisor or the platform is providing, or in some cases in ability for it to provide specific services that we need in order to deliver our solution. So that's gonna come up as I explain it a little further. So I'm gonna take a little pause here and say, any questions so far before I get into what we can do in our architecture?
I have a quick question, Deepak, and it's not really a technical one, but from a customer's perspective that you see, do you see a big use case for this? Is this something you see from the ground, or is it something that you've added to the product, or you know?
Well, we added it to the product because we see it coming up quite a lot. So not just philosophically, but having studied the market for the last year and a half in this area, I see two camps. There are what I'll call born in the cloud companies that will probably, the folks there will never know what a VM is, will never know what a server looks like, and they're truly rely on this as an architecture. And they can build an application like Gmail or YouTube that is globally distributed and won't need traditional data protection. But where we kind of hit a gate and saw an interest was the tens of thousands of traditional enterprise customers that want to be more cloud native in their application deployment. And we've seen a considerable uptick in that. And when I polled our existing customer base, and I looked at some of what they were doing, they're at the cusps of, majority of them will say within a year, they're going to be in production with Kubernetes-based applications. So they need to start thinking about some of the more advanced services to meet their SLAs. So that's in our observation and what we've seen.
Okay, thanks.
So for Zerto for Kubernetes, a couple of features or qualities that we kind of stuck to. First off, we changed the point of view of the way it works. Today in traditional Zerto, we come into an existing VM environment, we get deployed, we look at what's available, and we give you the choice to say, hey, what do you want to put into a consistency group? Somebody earlier asked the question about how do we figure out what an application is. With Zerto for Kubernetes, we took a reverse approach. We made it more of a DevOps centric. What that means is just as part of code, you're defining the infrastructure you require, how much CPU, how much memory, how many copies of your application, when to scale, etc. As part of that manifest, you will define the Zerto terminology. In other words, you will say, I want to be part of this consistency group. This MongoDB plus this Kafka streaming really are part of one single application in Zerto. I want you to treat this as a single consistency group. And what happens with that in terms of replication journal configuration. So make it part of the front end process that the application folks or the DevOps folks will push out rather than a back end process. And that's been received, very well by a lot of our alpha customers and our design partners. So that's a departure, and we think that it's going to really benefit this environment. And we're calling it data protection as code. The other parts of it is it's obviously based on our continuous journaling, data protection and journaling technology, specifically for the persistent volume. So very, very low RPOs delivered right out of the gate. We're talking about seconds here. Getting the persistent data is good. It's important. It's a very critical component. However, getting the shape of the entire application. So draw an analogy again to a traditional VM centric world. We need to know the vCPUs, we need to know memory, we need to know how the disks were connected, and all the things that will allow us to bring that VM up at a target site, whether it's at a remote VM site or as infrastructure as a service. In the Kubernetes environment, we are capturing equivalent components, the manifests, the services, the deployments, the stateful sets, the config maps, the secrets. So everything, again, we need to recreate that application wherever the target may be. It's continuous by nature, so there is no starting and stopping. And I think this is even more so important in the containerized world, because the idea is that 24 hours is an eternity. If I'm in a truly CI/CD environment and my developers are pushing changes into production multiple times a day without having to go through the traditional change control that slows me down, that's the whole benefit of CI/CD. What value is a backup that occurs once a day? That's an eternity, the amount of things that can change. So the continuous nature really starts providing a lot of value for us. And then on the left side, some of the use cases that Hei's already talked about, and I'll demonstrate these, but they carry forward. We still have the need to click a button and fail over a workload. We still want the ability to say, oops, maybe I failed over by mistake, let me fail it back, or let me roll it back. Let me pick a point in time that I want to be able to recover it. Let me make sure my environment's working. And then lastly, how do you manage this? Because if you are a DevOps person or you've worked with DevOps folks, it's all about the command line. It's all about APIs. They're back in fashion. It's super sexy to be able to use the command line, and GUIs are kind of passé. There's a place for a GUI, and I think we're going to hit that one right. So what we've done as part of that is actually integrated into the kubectl command. So you've got kubectl Zerto commands where you can execute. So if you're building part of your application deployment, you can easily make data protection part of that process, whether it be testing or failover or even adding new applications to existing consistency groups. And obviously, it's part of our core platform. So let's get into kind of the architecture and what we did. We took the core intellectual property, the stuff that makes Zerto down at the core, which is our ability to capture those IOs from a block level, as Hei's made my life a lot easier by explaining that earlier, and the replication engine itself. And we ported that over, rewrote some components so that it can run itself as a Kubernetes application. So what what today runs as a virtual appliance on an ESXi host or a Hyper-V host now runs essentially as a privileged stateful daemon set within a Kubernetes cluster. The beauty of that is Kubernetes takes care of scaling that. You add more nodes, it'll make sure the Zerto components come up. If it dies, it'll make sure that it's restarted. And so obviously the entity is stateless, but it connects to stateful data at the bottom. And then
Deepak,
we've got, yep.
I have a question about the container image. Is it a Linux-based container image, I assume?
Yes.
Okay. Because I noticed that most of the other Zerto components that we've looked at before, like the ZCA, are all Windows-based.
Yep.
And
go ahead.
When I think about that, just to apply this back to cloud and some of the costs involved in cloud, it tends to be much more expensive to run a Windows VM than a Linux VM in cloud. So could you take this updated code and push that back to the ZCA to run a cheaper instance in the cloud?
Have you been peeking at our future roadmap that I'm not supposed to talk about?
No, I'm just connecting dots, my man.
You're connecting the right dots. I will neither confirm nor deny that.
Fair enough. Fair enough.
All right. No, that's you're hitting the nail on the head. This is, from a vision standpoint, really enabling us and will enable us to expand into a lot more cloud native things. So when you start thinking about PaaS and SaaS, etc., this is going to start being some of the underlying architecture that will allow us to bring Zerto-like functionality to those areas as well.
I have another question. I mean, while it's pretty clear in VMware, the data path and where you can see to, intercept of the writes, in a container world, in Kubernetes, where you have persistent volumes that can be file or block and different kind of storage, and there is no actually a hook point, something that where you can sit and filter all the traffic. The technology is not the same at the end. I mean, you had to find a different way to do it.
Yeah, no, you're absolutely right. So this is where we actually elevated the point at which the driver sits. So rather than sitting at the hypervisor level, it's now sitting at the worker node level. Because in here, think of it, the ZRE, the replication engine itself, is being deployed on every worker node as a privileged stateful daemon set. It is not then putting a service on the worker nodes to saying, I'm now an IO splitter. And what we're supporting out of the gate is block volumes that are part of the CSI framework. So CSI, in a way, has made life a lot easier for us in that it could be an EBS volume underneath, it could be a PD from Google, it could be a virtual disk coming because you're running it in a VM environment. That block level interception, which we've perfected over the last 10 years, is what we've ported over. And that's always been core Linux. So that's also allowing us, now you kind of think about the architecture, it doesn't really matter what hypervisor platform you're running on. I can make this universal, whether it's OpenShift or Tanzu or GKE or AKS or EKS, where we're just running as a Kubernetes application. So hopefully that answers the question.
Not 100%.
Okay.
But maybe we will go through it later. I mean.
Okay. But we can always take it offline later. But if I don't hit it, please bring it back up.
So the problem for me is that you may have a driver at the kernel level or something like that, but with more and more storage system that work at in the user space directly providing using different IO paths, it becomes really complicated to manage all the storage system over there. But maybe I'm missing again.
No, we're in the user space and we're intercepting the IOs at higher than the driver. So let's assume you've got a physical node and you're running traditional fiber channel block storage underneath the covers. That block storage for Kubernetes is providing you a CSI framework where it's presenting the persistent volumes. What our filter driver, again, it's the same filter driver, is able to do is map from the pods that you're deploying, the persistent volumes that those specific pods need, down to ultimately, in the end of the day, where's that block device with where it's
does it mean that when the CSI provides the persistent volume, you sit in the middle between the persistent volume and the pod?
Exactly. But it's also out of path in the sense that you can turn off the Zerto components and we're not going to affect your IO.
Okay. Well, I would like to see a diagram because there is something
for the deeper components. Sure thing.
Okay.
So the other component. So I've talked a little bit about the ZRE and the questions. There have been very good. The other component is the manager side of it, where we introduce what we're calling a light version of a manager, and that's talking with our SaaS platform as well. So you can essentially do all your API, UI, CLI. Reporting, etc., from that component itself, and it checks for licenses, things like that. So it's really just 2 lightweight components, and I'll show you in the demo from an installation, what gets installed where in a specific namespace, etc. And then you can deploy obviously these in multiple clusters, and the Zerto manager will hook up the different clusters and allow you to do DR, failover, etc., all of the operations. So it's a really, really simple architecture that we've deployed for this. All right. Where the GUI comes in, so there's a time and a place for GUI, and even in this environment, and specifically where the intersection with our existing platform is in our alerting. So Zerto Analytics and our reporting, alerting, and dashboard. We'll be introducing a new tab within what customers see today in their dashboard, and we'll be able to report similar concepts. We'll be able to report what their consistency groups are, the statuses, what the workloads underneath they are, what we're protecting, journal history, status, etc. So it's the things that you traditionally get from Zerto. So I'll kind of bring a lot of this, and then what's on this screen will become very clear as I get through some of the GUI, some of the demo part of it, sorry. Okay, 2 other things. Just this week, we launched and announced a sign up for alpha customers. So it is a little exclusive in the sense that we're handpicking customers based on their environments just to keep it balanced. But initially we've had a good response, and we've put it out publicly so customers can essentially go out there and sign up, and they'll be able to try this in their try everything I'm showing you in their own environments. And we are obviously love them to do this and give us some brutally honest feedback. That's how we can make the product better. Our goal at the end of the day is to provide the same use cases, right? Which is 1, disaster recovery, going across clusters, whether that clusters are in your own data centers or across to a different cloud platform, or even across different platforms. The operational recovery pieces, so being able to recover within the cluster, being able to restore back very quickly to a point in time from the journal. Long-term retention will get added in as we get closer to GA. Hybrid and multi by nature, hopefully I've explained that very well because of the architecture. It doesn't really matter the platform underneath. And then all of the cool things that our customers do with our journaling and our failover test capabilities. So maybe I want to create a quick isolated bubble and do some sort of regression testing off of a production copy. I can very easily do that, including the persistent data. So I'll show some of that. At Alpha announcement at ZertoCon, we announced and we partnered and announced and tested with these the logos are below. It's obviously upstream Kubernetes. We support that right out of the gate, 1.15 and upward. OpenShift, EKS, AKS, GKE, as well as the IBM Cloud Kubernetes offering, and VMware Tanzu. So working closely with these partners, just as we've done in our traditional areas, to be able to support their offering of Kubernetes and Kubernetes as a service. So I'll switch my screen now to demo. And I have been advised, and I think that was good advice, to actually do this as recorded, so you don't have to see me muddle through commands, but I will make this full screen for everybody. Okay. So the first part of it, I'm going to go run through a simple installation. So if you're a command line Linux person, you'll enjoy this. If you're not, you'll learn something new. But I tried to make this pretty basic and educational from a standpoint, just to kind of show the functionality. So you're not going to see me do a lot of fancy things, just kind of simple basic stuff. And I'll narrate the director's cut of this of these clips as you kind of go along. So we're delivering it via pull from a Docker Hub library. We've put it into an installer script that just basically under the covers runs a whole bunch of kubectl apply commands. And what it does is creates the various Zerto components. So you'll see it's asking me for my password. I have access to our alpha registry. It will create a Zerto namespace. So we're putting all the Zerto components into a Zerto namespace. It'll create the service accounts, and then it will create all the necessary secrets, the generated, etc. and it will then create our management pod that I talked about. So this was running live. It's a very, very lightweight application. I think the pull is about 270 or 280 megabytes, very, very, very efficient. And it will go through, and a couple of minutes later, it'll say, yep, the Zerto virtual, the manager component of this is done. So then and by the way, this was just a fresh EKS environment I was doing on Amazon, nothing special. It was launched in EKS, version 1.15, 2 worker nodes behind the scenes, and connected to it from a Linux workstation. So it'll install all the Zerto components from there. Obviously, in the background, it has EKCTL to be able to communicate with space. So you're going to see the Zerto pod is the only pod that I have running. And when I listed the pods for all the namespaces, you'll see the 2 Zerto components come in. So this is running one per worker node, since I have 2 worker nodes, and this is it in terms of components. And then we've got a proxy. It's essentially an HA proxy that allows workload to be distributed across the 2 ZREs, and it allows the replication engine to the replication engine cross communication, etc. So you then don't have to do a one-to-one mapping. It's all handled from a high availability standpoint. And those are all tucked away in a Zerto namespace. So that's pretty much for the installation. It takes less than 3 minutes to get the environment up and running. So what I'm going to next show is some very basic persistent volume creation and protection of persistent volumes. What we included with the alpha is a very simple Debian container. So in order to do that, obviously, I could use the default storage class, but not, especially if you're talking about on-prem environments like OpenShift, you may not have a default storage class. So what we'll do under the covers, it is scripted, but I wanted to actually demonstrate it here. I created a storage class that's relying on some EBS storage underneath the covers. So that's my simple storage class for demo purposes. I'm going to apply that and create my storage class. Then I am going to create a persistent volume claim from that storage class, and I just called it my persistent volume claim, and it's coming from demo class. It's just a 1 gig volume claim. And I'm going to go ahead and create that within Kubernetes. So a good thing about videos is you don't have to watch me make typos on the screen. Next, I have a deployment. So that uses that persistent volume. And it's a very basic deployment. It is, of type deployment. It's an app, I'm calling it my Debian. It's going to ask for 1 replica in the environment. And it's pulling the current Debian stable image. It's running a tail command just to keep the image up and alive. And I'm mounting that persistent volume under var PV path, as you can see from here. So there's my mount path, and here's the claim that I'm taking for this container. So every time this container goes away, it gets restarted, recreated, etc., it'll always come and connect to that persistent volume claim. So again, beauty of Kubernetes being able to make the container ephemeral and detach it from the persistent aspect of it. So we'll go ahead and create that deployment. And I'm going to check just to see my persistent volume claim. There's my persistent volume claim I've got. It's 1 gig. It has read-write access. It'll be deleted, and it's attached to that pod. So I'm going to go and get my pods, Kubernetes, and it says, yep, there it is. There's the container. It's being created. Wait a couple of seconds, and there we go. My container is running, and it's got persistent attached to it. So I'm going to connect to that pod now, and I'm going to do nothing than just run into the shell. So nothing super high level, but what I'm interested in is going into the persistent data, and is where the persistent data volume is, which we told to be in PV path. So as to make this demo very simple, I said, let's write some important information on that persistent data, on that persistent volume, which Zerto can then essentially protect. So I, in the sake of simplicity, just echoed a bunch of text into a file. And I also created another file, and it just said, hey, this is another important file. So I end up with essentially two files sitting on that persistent volume, which is an important file and then another file. Just for the sake of demonstration, I exit out of that container. And now I'm going to do some Zerto things to show you the Zerto parts of it. So the first thing we talked about, data protection as code. And let's say this is an application, I've got it in running in production, and I say, oh yeah, now I want to start adding it to a consistency group. So all you have to do from a deployment standpoint is go back into the manifest and add an annotation which says, what protection group do I want to be? Do I want to make this deployment part of? And I'm just going to call it, my first protection group. That's all that's needed from the front end to put that application into that consistency group. Super simple, don't have to go scan for containers and have pods and having to move them around, etc. And I'm going to apply that. So Kubernetes will say, yep, I understand this is updated. And now I've got an annotation in there as well. Nothing in the pod really has changed. It's still up and running. Everything is as it was, except the manifest has been updated. So on the back end, so now let me focus, that was the DevOps side of it. Let me focus on the IT side of the DevOps function. So this is where I, as a traditional Zerto person, would say, yeah, I want my first protection group to really have these parameters. So back to if you remember the journal question from earlier, not only can I define, the length of the journal, the capacity of the journal, all the attributes that I care about from the IT side, because at the end of the day, we would like to believe we have infinite infrastructure, but we know we're still limited by somebody has to, by what's available from a resource standpoint. So the IT side of this is saying, my first protection group, I want very simply, the only two things we need is where's your source and where's your target, and if there's anything you want to do different from a recovery storage class. Obviously, I can expand this. It's very YAML based into specifics on journal history, times, capacities, orders, etc. The second part that we've done is added in the Zerto command as part of kubectl. So you put in kubectl Zerto, so plugin that gets installed. It's a simple binary that expands the kubectl structure, and it's very command based. So you can see some of the commands that are available here: commit, create, delete, etc. And we'll get through some of these, and I'll explain what these are. And obviously, the help is built in part of that. So what I'm going to do next is we're actually going to create that protection group. We're going to clear the screen just to make it simple, and I am going to create that group. I'm going to tell Zerto to create a consistency group based on that BPG, on that protection group configuration. It says, yep, I got the task, and I will execute that in the background. So that's our first command, to be able to create consistency groups. And then I'm going to get, which means I'm going to say, hey, how's it doing and what have you done? What have you got in it? So what is captured in there is obviously the name I created it. It's creating right now, but it's identified from the application that this was associated with one deployment. That's one it. Had I deployed, let's say, WordPress that had 443 and 80 as a service, then I would have picked up the services, the config maps. Essentially everything I need from that application, from that running application, to recreate it somewhere else. So we're protecting all those elements. Additionally, of course, we're going to recognize the fact that there's persistent data behind it, and we'll start protecting it. So it's protecting right now, but you'll see the number of checkpoints. In other words, those journal checkpoints are 0. So I wait a couple of seconds, and I issue that command again. And we're going to see that I already have 5 checkpoints that I've generated in that time period for that deployment. And I will then go and actually list out what some of those checkpoints are. So give you a visual of what that journal actually looks like from a user standpoint. And all I'm doing is getting checkpoints for the protection group that I specified. And here we go from a timestamp perspective. All the times that are created, all the checkpoints are ID'd. And as you can see, we're running about 5 to 6 seconds in terms of recovery points. So you've got all of these points that Zerto can already recover to in terms of your persistent data. So next part, you can obviously tag checkpoints. Let's say you're about to do something important to that application. I'm about to make a big modification, make a big push. And I know that the whole idea of Kubernetes is you should be able to put that in, roll back to a previous version. That's great for the deployment, but what about the persistent data? How do you get that persistent data back to that point in time? And that's where we're really providing the value and shining. So I'm going to tag that checkpoint because I don't like to use lots of big numbers. I'm going to say that please put this as a good checkpoint where I know things were good. And now I'm going to tag that so that when I do a display of my checkpoints, I actually get a very human-friendly checkpoint. You can see, obviously, the checkpoints have increased quite a bit there, and that's my good checkpoint where I know things are good. Next, I'm going to go do some bad stuff. So I'm going to go connect back into my running container, and I can just getting the full name of the container, and I get into my I get into my container, I get into my persistent volume, and I actually remove that file. I delete that file by doing an RM. So my another file is now gone, and all I have left is my important file. So let's assume bad stuff happened, and it happened in a very short period of time. And I'm just for my own identification, I tagged that checkpoint as well. I said, Zerto, I want you to tag that checkpoint with something that's happened. And we said, the file's been deleted there, so I'm going to tag that checkpoint. And we're going to go look at our checkpoints. And you can see there's my time delta between when stuff was good, and there's a checkpoint where I just created, I noticed that something bad's happening in my environment. So again, this is within one local cluster. So let's do some more Zerto things. I'm going to go into Zerto and I'm going to say, you know what, I'm not quite ready to do a restore yet, but I really want to check if my good checkpoint is good, right? So we may not always have the luxury of going back to a good checkpoint. And for that, we have Failover Test. It's a function that customers use today where they'll pick any point from the journal and see if things were good, if they wanted it, right? And I'll ask you in your back of your mind to try and draw an analogy with a ransomware attack. You don't really know when the good point was, but boy, it would be really nice to let production hang out for a little bit longer before I really know where that good checkpoint is. So I'm going to tell, and by the way, any command that you run, we give you help there in case you don't get all the parameters correct. In this case, all I need to say is do a failover test for this consistency group, and I want you to pick a specific tag checkpoint. I can give it a number, but again, the human readable just makes it a lot easier. So what Zerto is doing under the covers now is it is starting a failover test. And I do a get VPG, it'll say, yep, for that protection group, I am in a failover test status. I'm gonna wait for it to do what it does in the back end, which is essentially create pods. So I do I'm going to pause here and explain a little bit more. So what it's done in the back end, as you can see, for that original workload, we were maintaining not only a a journal volume that the replication engines were handling, but we've quickly created a scratch volume from the journal and from the target disk so that we can then mount it and have it available. And where it's available is to a failover test pod. So as part of the VPG configuration, we've built the rules that say, hey, and prefix everything that you're going to do in a failover test with FOT, just so you don't get the containers confused, and also put in an FOT namespace. So what's been created is a failover test namespace, as well as a failover test version of that. And what that container and that pod has is that persistent data from that checkpoint that Zerto has then presented to it on the back end. So I'm going to actually, and it's been running for about 2 minutes. And there's the scratch, and there's the claim volume. As you can see, the disk J, my persistent claim, is where we're keeping the target data available. So there was no target pod that needed to be created. We were maintaining the recovery volumes as well as the journal files we had. I'm going to connect to that failover test pod, and let's see if it was good. Let's see if all my data was in there, and it's actually the point that I will eventually restore to. So I go back into my persistent path, and it's a new pod. We've kept everything exactly the same, and I see, voila, I've got my file. Life is good. I'm not sure why I added the other file, but it's there. My data is good. And then journaling is occurring, and I'm kind of good with that. If it weren't, then I can obviously clean it out, and I can go try another checkpoint. So in this case, I'm going to show you the cleaning of it. I get and by the way, we're still in our test failover mode. So I'm actually going to go ahead and stop that test for that checkpoint, or for that consistency group. It runs, I do a check, it says, yep, I'm stopping my failover test. I wait another 60 seconds or so, and then I say, okay, how are you doing? And it says, yep, I'm back to protecting it. But the important thing here that the reason I'm highlighting that 145 is you haven't lost any of that journal history. You tried it out, you checked it, but in the background, we were still protecting the production workload and creating checkpoints as for that persistent data as life went on. So now what I'm going to do is, we're good. We actually want to do a restore back into production. And by the way, I'm just kind of trying to see the cleanup first. So both my failover test container and my failover test -default namespace has essentially gone, cleared that out. So let's do another Zerto thing. In this case, we are going to do a restore. So I type in the restore, and it will ask me for, or I specify my protection group that I want to restore, and the checkpoint that I want restored from my journal history. It'll submit the task. Let me go look at what my consistency groups look like, what's happened to the replication, and it'll say, yep, starting a production restore test. So the pod's disappeared. We destroy the pod in the production. We have got the point in time back that we need. We're rolling back the persistent volumes to the point that you want to get to. And then we're recreating, asking Kubernetes to redeploy that deployment at that point in time. And that's done, it's created, it's been up and running for about 18 seconds now. So I quickly go in there and I connect, and I want to just make sure that, hey, that my persistent volume is there, and I actually have the data points in there. So why am I showing you, the reason that the restore is in a state? Because the restore is not complete yet. What I mean by that is that you still have to commit a restore. So in case something goes wrong, or oops, this is not the restore I meant to do, we always put a restore into a pre-committed state. And it's restored, it's working, you can do everything you want, but we want you to do one more step, which could be done automatically in a timeout manner, which is what we do, today in a VM standpoint. But we're in a before commit state, which means, are you sure this is what you really want to do? Is everything in production up and running? If so, go for it. So what I'm then going to do is say, yes, Zerto, please go ahead and commit the restore. So what Zerto in the backend is going to see, all right, I'm going to now forgo all of the history that you had in the journal. You've basically told me this is a good point for me to go to, and everything, forward from this checkpoint, you're basically saying is bad, and it commits that into production. And I will do a quick get checkpoint, get a VPG, and it says, yep, I'm syncing it up again, and I am starting protection again. So you've essentially reestablished production to a restored point, and it then continues that protection from that point, and the checkpoints, and start from that point in time. So this is it's functionality that we have in our VM side from a DR standpoint, but the important thing is we're doing this within a single cluster. So it's a completely different take on your traditional, I got to backup, and then I got to find where my backup is, and then I got to go restore, or I have to even do snapshots on my environment, which how frequently can you schedule those snapshots, and how do you manage a snapshot orchestration? We're doing this in a continuous manner, under the covers. So I don't have to go through the setup stuff anymore. What I will describe in my environment is I had a local workload running production local within my production environment, but I had two workloads in this case with two separate persistent volumes attached to each one, running across sites. So this could be within the same region, across zones. It could be across regions. It could be on-prem to cloud. Really doesn't matter from our standpoint. And I connect in there, and I have a super important transactional application that basically puts the UTC time into a file. And I have them synced up, so they're both putting essentially the same data, or concurrently putting timestamps into two different clusters. Go past the prove that part. From a DR standpoint, essentially all you've done in the VPG is said, Zerto, take this VPG and put it this protection group from production to recovery. And on the recovery side, there's another Zerto running there, and all that's running is just the ZVM and the components that I showed you as well. And I specify, obviously, the storage class, and you can see I've been protecting one workload, production to production. It's been running for a day, and this was done later on, so the development folks have been adding more and more features. I can now start seeing my RPOs as well as my journal history for each one of the workloads. But the one that we're concerned about is the one that's running, production to recovery across the different sites. The remote site, all I have running is from a default namespace is just the light manager component, but we're maintaining the volumes, and we're maintaining the journals for each one of those applications. I go create a checkpoint, which is very, it should be second nature to you from my first demo. And I say, yep, this is my checkpoint for this one. And now what I'm doing is a failover test. So just like we did a failover locally, within the cluster, this is happening across clusters. And what it is doing is says, yep, I am going to start a failover test of this production environment. It's still journaling. And on the remote side, once I get in there, you see that after a few minutes, things start showing up. Additional pods that we create start showing up. So I'm kind of waiting for that. The scratch volume starts getting created. And then a few minutes later, I find my failover test namespace has been created, and these new deployments have been created. The containers, one's pending, one's creating, and I wait for them to essentially get into running state. I then go in there and I connect to it, and I see, yay, my data is there, and it's there up to my existing checkpoint status. I can stop the test and not lose any of the journal history. I still have 15 hours and 33 minutes worth of journal history that's running across the environment. So again, this could be a DR scenario or migration scenario where you're testing a point in time. Finally, to end it, what I wanted to do was essentially do a live failover of that production workload. But very similar to Restore, we built those states where you're starting a failover. You can roll that failover back if you decide, oops, sorry, this was not the wrong point in time, or we decided to, go pull back. And the number of customers on the VM side who've thanked us for that functionality over the years just proves that it's that exists from a human standpoint. And then commit. So when you're truly sure that you want to be able to lock it in, you can commit it. So I picked that my checkpoint, and I essentially do a failover live. It starts the failover live, but it will be in a pre-committed state. On the remote side, I log in, and now instead of it being in a default failover test namespace, this actually now has created those pods at the remote side on that remote cluster, and brought them up as they were running production. So if there were services, et cetera, load balancers, they would all get deployed as part of that failover. Lastly, I come back in here and it says, yep, it's before a commit. So you're good to go with that one. You can issue a commit command, and then it will essentially commit that to the remote side. And now you've failed over your workload and you're running on your remote side. So this is what we've built, and that's been cleared out, so I can set up reverse replication as my next step. But you're getting the idea. It's a lot of the similar things, but you're just using it in more complex use cases.